Hello and welcome to Mrunal's Math Tutorials, and in today's tutorial we're going to look at some probability and Venn diagram questions. I'll be revising some important topics and discussing some past paper questions. Before we start, make sure that you subscribe my channel so that you get my updates on a regular basis. Let's begin. So the first question is about a typical question about cards. So we have over here, the diagram shows 7 cards. Amir picks a card at random. Find the probability that the card shows the letter H. So in such questions, it's pretty easy because it's 1 mark. So you got to think about how many cards do you have which have letter H. So I can see over here, this reads as Namibia. That means there are 0 cards with letter H. So the probability would be 0. There's no need to write down 0 over 7 or something like that. You can simply write 0. Then next one, find the probability that it shows the letter B. So we have 1 card that shows letter B out of 7. So the probability would be 1 out of 7. Part B, Fumika picks 1 card of the 7 cards at random and then she replaces it and picks a second card at random. Find the probability that both the cards show the letter I. So first of all, you need to identify how many cards do you have with letter I. So there are 2 cards with letter I. It means that she has 2 cards to choose from in the first pick. So 2 out of 7. Now, since she is replacing the card, the total in the denominator will still remain 7. And again, she has a choice of 2 cards to pick from because she replaced the previous I. Yeah. And now she's picking the second I card. So that would be 4 out of 49. Remember that you must write your answer over the answer line. Part C. Macros picks 2 cards of the 7 cards at random without replacement. It means that your total will change. Find the probability that 1 card shows the letter I and the other cards shows the letter N. So we know that there are 2 cards with letter I and there is 1 card with letter N. So we're thinking about picking 2 cards without replacement. So let's say he picks first the letter I. So there are 2 cards out of 7. Then he picks the letter N. Now he did not replace the card. That means the total is now going to be 6. So there is only 1 card of letter N. So this is going to be 1 out of 6. Or it is possible that he may first pick the letter N. So that would be 1 out of 7 times. Then he thinks of picking the letter I, which would be 2 out of 6. So let's work this out. This is going to be 2 out of 42 plus 2 out of 42, which is 4 out of 42. That could be simplified as 2 out of 21. Now part CII. Find the probability that the 2 cards show different letters. So here, remember, they did not specify which letter, but they have to show different letters. So what could be different? Let's see. Now here we are having 2 cards with letter A and we are having 2 cards with letter I. Right? So the easiest way to solve this would be to try and choose 2 cards with same letters, and then we would do 1 minus the cards with same letter to get the probability of 2 cards showing different letters. So I'm going to calculate the probability that the cards show same letter. Right? So here we have a choice. Now again, we could pick both the cards with letter A, or we could pick both the cards with letter I. Right? So for the first card, it is going to be 2 out of 7. Again, it's without replacement. So we're going to put 1 out of 6. Or there are two i's again. 2 out of 7 times 1 out of 6. Let's work this out. This becomes 2 out of 42 plus 2 out of 42, which is 4 out of 42, or 2 out of 21. And then 1 minus 4 out of 42. This is going to give me the probability that the cards show different letters. So this is the easiest way to work out this example. Yeah. So that is going to be 19 out of 21. So your final answer is 19 out of 21. In the same question, part D, Nina picks one card of the 7 cards at random without replacement. She continues to pick cards without replacement until she picks a card that shows the letter A. The probability that this occurs when she picks the nth card is 4 out of 21. Find the value of n. What does this mean? It means that she continues picking the card until she finds the card with letter A. And they say that the probability that this occurs when she picks the nth card is 4 out of 21. So we are not sure when is she picking the card with letter A. But we know that when she picks it, the probability is 4 out of 21. Alright, so the easiest way to work this out would be to try and pick the cards which are not letter A. So either she would pick a card with letter A or without letter A. So we have 7 cards in total, out of which 2 cards are with letter A. That means the remaining cards should be not letter A. That are 5 cards. Okay. So let us say she was very lucky, and in the first pick she is going to pick a card with letter A. So there are 2 cards with letter A. Yeah. So this is the first pick, that would be letter A. So 2 out of 7, that is not equal to 4 out of 21. So that's not true. Let's say second card she picks is letter A. That means the first card should be something else, which would be 5 out of 7. Right? Now this is again without replacement. Okay, we said that the first card she picks is not letter A, so it could be any of the other cards, which is 5 out of 7. So then the second card she has to pick letter A, so this would be 2 out of 6. So this gives me 10 out of 42, which in simplest form would be equal to 5 out of 21. So this is still not 4 out of 21. Yeah, so probably maybe the third card she picks is letter A. So the first card is not letter A. The second card is not letter A. So again, we are doing without replacement. So this becomes 6 and this becomes 4. So this is going to be 4 out of 6. And let's say now the third card she's picking is a card with A. So that would be 2 out of 5. Let's work this out. This works out to be, I think it's equal to 4 out of 21. So what does that mean? It means that she picked the card with letter A on her third pick. So the value of n is equal to 3. Alright. Let's move on. I'm going to revise a little bit of Venn diagrams as well, because mostly probability and Venn diagrams, they come together in the exam. Yeah. So what do we have here? The Venn diagram shows that the number of students in group of 50 students who wear glasses and who wear trainers and who have mobile phones. So we have total of 50 students, all right? And these numbers are the number of people who are either wearing glasses or they're wearing trainers or they have mobile phone, right? So use set notation to describe the region that contains one student. So this is outside all of this. Yeah, so what is all of this? This is the union of the three. Okay, so union of G, M and T. So when we shade all of this, that means it's the union. Now it is outside the union, so it's not in the union. So we represent this by this sign over here. It means that it's prime, that is not, or prime, we can call it as prime. Yeah. Now we need to find number of elements of T prime, means not T, intersecting with G union M. All right. So let's see what do we have in G union M. So this entire part represents G union M. So I need G union M that intersects with not T. So not T, that means you leave the T. So we are interested in this part here and this one. Yeah. So that's going to be 9 plus 19. So because all of this is outside T, not T, but it is still intersecting with G union M. So that's going to be equal to 28. One student is picked at random from the 50 students. Find the probability that the student wears trainers but does not wear glasses. So he's going to wear trainers, but he does not wear glasses. So if he is not wearing glasses, but he is wearing trainers, so no glasses, so ignore this. Yeah, let's ignore this. So what are we left with? We are left with 3 and 4. 3 and 14, sorry, 3 and 14. That means a total of 17. So 17 students left out of 50. That would be the probability. So in part 4, we have 2 students are picked at random from those who are wearing trainers. Find the probability that both these students have mobile phones. So now we need to pick students from those who are wearing trainers. So let us count how many students are wearing trainers. So that would be 2 plus 2, 4, 4 plus 3, 7, 7 plus 14, that is 21. So we need to pick from 21, right? And we have to pick 2. So when we are picking this next one, obviously the total will change. Yeah. And we need to pick such students who have mobile phones. So let us see how many have mobile phones. So we can see over here that there are 16 students who have mobile phones. So when we pick the first student, it's going to be 16 out of 21. When you pick the second one, obviously this is going to be 15 out of 20. Let's work this out. This is going to be 4 out of 7. You got to remember that if it says specifically picked at random from those wearing trainers, many students would end up writing 50 here. But now we need to read this carefully and write down the correct denominator. Let's move on to the next question. The Venn diagram shows the number of students in class of 40 who study physics, mathematics and geography. Use set notation to describe the region that is shaded. So we can see over here that a part of M and G is shaded. So I'm thinking that it is a union of M and G. But then this part is being removed out of it. So what is that part? It's P, right? So we would say that this is going to be M union with G, and it is intersecting with the part that is not P, because nothing of P is shaded. So we are shading everything outside P. But which part are we shading? We are shading M union G, right? Okay. Find N, that means the number of elements of P intersection G. So we're thinking about P intersection G. So all of this. Union with not M. Union with not M. So we're thinking about P intersection G. Okay. All of this. And not M. So not M would be outside this. So it's going to be very easy. So when it is union, you got to remember you have to select P intersection with G. So what is P intersection with G? This is the union. Okay, we are looking for the intersection. So intersection is just going to be 3 plus 9. Yeah, so 3 plus 9 plus, we need to select everything that is not in M. Not in M is also 4 and 6. Yeah, plus 4 and 6. This works out to be 22. A common mistake is to ignore the 4 and 6. Unions means plus. You need to select everything along with the intersection, right? Okay. Part C, a student is chosen at random from those who study geography. Find the probability that this student also studies physics or maths but not both. So now we are choosing students from geography. So we are looking at the geography circle. Yeah. How many students do we have in geography? That would be 12 plus 11, which is 23. So from these 23 students, we need to choose, we know that the total is 23. Yeah. We need to choose a student that studies physics or maths, but he does not study both. So it could be either 3 or 5, but not 9. Yeah. So this is going to be 3 plus 5, which is 8 out of 23. That's it about this question. Let's move on. Next question over here. Use set notation to describe the shaded region in the Venn diagram. So I can see that A intersection B has been shaded. The middle part represents the intersection. What if all of this was shaded? Then that would have been the union. Alright. Part 2. Shade the correct region in the Venn diagram. Q union with P complement. So Q union. As I said earlier, union means everything along with Q. So we need to shade everything that is Q. I'm just going to use the highlighter over here. So Q union with not P. So what is not P? So leave the P and everything outside P would be not P. Do not get confused with the intersection. This is union. Okay, intersection would be only half the circle of either P or Q. Yeah, that would be the correct answer. Next, we have K union L intersecting with not M. So K union L is all of this. But now this is intersecting with not M. Not M is outside the circle of M. So we're going to shade the part which represents the union of K and L but does not include M. So we're going to shade only this part over here. Alright. Part B, the diagram shows 11 cards and it reads Venn diagram. One of these cards is chosen at random. Write the probability that the letter on the card is not A. So not A. How many cards are with A? With A there are 2 cards. So the remaining 9 cards are not A. So 9 out of 11. A card is chosen at random from these 11 cards and then replaced. A second card is then chosen at random. Find the probability that exactly one card has letter N. So let's say the first card has got letter N, and that would be, how many N's do we have over here? So we have 2 N's, yeah. So he has a choice of 2 out of 11. The second card is not N, right? So that's going to be 9 out of 11. Why 11? Because the previous card is being replaced. So this is going to be 9 out of 11. So I'll say not N. Or it's possible that the first card you choose is not N. So this is 9 out of 11 times the second card you choose is N. So 2 out of 11. So this works out to be 18 plus 18 over 121. Yeah, 18 plus 18 over 121, that is 36 out of 121. Right? Part C, this is one of the typical questions that you can expect. 50 students are asked if they like English and if they like maths. 3 students say that they do not like English and they do not like maths. 33 say that they like English, 42 say that they like mathematics. Alright, so we have 50 students here. We need to complete the Venn diagram. We can see that there are 3 students who do not like either English or maths. So that's going to go outside. So how many will go inside here? It is going to be 50 minus 3, which is 47. But I do not know how many students like both. So for now, let's say this is X. So there are 33 who like English. So all of this is 33. So this is going to be 33 minus X. I recommend to do this with pencil. And then maths would be 42 minus X, because X is in the middle, right? So you can set up an equation with all of this. We know that all of this should add up to 47, as I said earlier. 33 minus X plus 42 minus X is equal to 47. So we can see that 33 plus 42 minus X is 47. So this works out to give us X equal to 28. So now we know that there are 28 people who like both English and maths. 33 minus 28 will give us 5. So that will go here. And 42 minus 28 will give us 14, which will go here. What happens if you don't want to set up an equation like this? Then the easy way is to add 33 plus 42. Okay, so that's going to give me 75, and then from 75 you minus 47, it's still going to give you 28. But I like to do it in this way because it makes more sense. Yeah, and it's easy to remember. A student is chosen at random. Find the probability that this student likes English and likes math. So he likes both basically. So we're going to choose 28 out of 50. So this is going to be 28 out of 50. It's not necessary to write it in simplest form because they did not ask that. Part 3. 2 students are chosen at random. Find the probability that they both like maths. So we know that they both like maths. So this is 14. Yeah. 14 plus 28. They didn't say only maths. If they say only maths, you would have taken only 14. They say maths. So you're going to add all of them. So that's 42. So the first student is going to be 42 out of 50. It's common sense, even if they don't say over here, if you choose one student out, the number of students will decrease, yeah? Common mistake would be to write again over 50 because it didn't say they did not replace. There's no need to say that the student is replaced. You would say that only if it's a counter, a marble or something like that, yeah? Or a card. So this works out to be 123 out of 175. That's your final answer. Let's move on to part 4. Two students who like English are chosen at random. Find the probability that they both also like maths. So we're going to pick students from English. So we're going to pick from 33. Now we need to find such two students that they also like math. So that would be out of 28. Yeah. So for the first student to choose, we have 28 out of 33. Then for the second student, it is going to be 27 out of 32, which works out to be 63 out of 88. All right. Next question. At a festival, 380 people out of 500 people were questioned. Say that they are camping. Yeah. So it was a random, probably a survey, and they asked 500 people, and out of that 380 people said that they are camping. There are 55,300 people at the festival. Calculate an estimate of total number of people camping. Alright, so they gave you the probability of people who are camping, and they also gave you how many people are there in the festival. So obviously the probability of people camping is this multiplied by the total number of people, 55,300. This is going to give you the total number of people that are camping at the festival. So this works out to be 42,028, right? Part B, 12 friends travel to the festival. 5 travel by the car, 4 travel by the bus, 3 travel by the train. 2 people are chosen at random from the 12 friends. Calculate the probability that they travel by different types of transport. Before we move on to this question, if you haven't hit the subscribe button, please do so, because it motivates me and also guides me. Comment me if you want to see some other topic. It guides me to make such more videos for you. Alright, so let's move on to the question. So we have to choose 2 people, and they should travel by different types of transport, but they did not specify which transport. So probably, let's say the first one goes by car. So we have 5 out of 12 going by car. Yeah, because we can choose out of the 5 people, we can choose the first one, 5 out of 12. And the other person has to go by either train or he has to go by bus, right? So train or bus. So that would be 7 out of 11. What does this mean? It means that to choose the first person going by car, I have 5 options. Yeah. And to choose the second person, I have 7 options, 7 out of 11. Or let's say the first person is going by bus, then the other has to go by car or by train. So if he's going by bus, so then that would be 4 out of 12. And for the next one, I would have 8 out of 11. I'm just simply adding car and train. Yeah, 5 plus 3 is 8. Or you might have guessed the next one. It would be by bus, then we finished, let's say, train, by train, and the next one would be car or bus. So by train, it would be 3 out of 12 times 9 out of 11. So this works out to be 47 out of 66. Part C. Arno buys a student ticket for $43.68. This is saving of 16% on the full price of the ticket. So 43.68 is saving of 6%. So basically it represents 100 minus 16. Calculate the full price of the ticket. So 43.68 represents a saving of 6%. That means 100 minus 16. It represents 84%. Yeah, it represents 84%. Now, we need to calculate the full price. So, if 84% is 43.68, how much is 100%? Easy to set up a proportion here and cross multiply. Then you can make x as your subject. So, x is equal to 43.68 times 100 divided by 84, and this works out to be 52. So, in today's tutorial, we have revised probability and Venn diagrams. If you haven't subscribed my channel yet, please do so. As I said earlier, it helps me, motivates me, and guides me to make more videos for your help. Please comment if you would like to see any other video, any other topic. I would be more than happy to help you. All right. Thank you for watching.